Okay, today we're going to be talking about geometric series. This goes along with geometric and arithmetic sequences based on the last tutorial. As always, I don't do the questions unless I feel that it is beneficial for you and going over the tutorial and the videos and stuff like that. I will let you watch that on your own. Some questions, like I said, I do go over, sometimes I don't. So let's talk about geometric series. Now, a lot of times too, geometry and algebra do kind of overlap each other with some equations and stuff like that. And you're going to see this in this tutorial as well. So this is sequencing, and I have a brief mini lesson on this one, the sequencing here, that I highlighted, that you can see that I've broken it down step by step so you can see how it goes up in the sequence. There's a little mini lesson on that. But geometric sequence, for an example, a sequence of numbers where the next term is determined by multiplying a constant number. Okay, so what does that mean? Let's read common ratio. In a geometric sequence, the ratio multiplied by each term gets the next term. Okay, so then look at here, we have A15. So we have these numbers listed. N would represent like the term, how many terms are in this sequence? Okay, well let's say there's 15. So here we want to find out A, this is the first term, R, n minus 1 power, and then you fill it in like this. So this is how you kind of figure out how to solve a geometric sequence. Now, like I said, I have it in another mini lesson where I've broken it down even smaller, so you can see each step by step like that. Okay, so let's get into this. Some more examples. A geometric series, a sum of the geometric sequence. Okay, so then it just tells you here, this is the sequence. Here's the examples. Here's our numbers. Here's like the number it is in the series. So here's like first, second, third, fourth, fifth term. And then here's like what as it goes up like that. Okay. Geometric sequence again. Here are information, more information about it. It goes into more depth. This might help you for the mastery test. If you are taking the mastery test, then I would save this information because this talks a lot about geometric sequencing. It gives you a couple formulas, breaks it down for you. Okay. All right, so this question I'll show you, just that you match the sequencing with the equation. So you'd have to do a little bit of equation solving here with the geometric sequence and figure out which term goes along with which equation and how. So pay attention to the beginning numbers because the beginning numbers, and this will make all the difference in the world because you'll see. So like for an example, this one starts off with 243, and that's why we match it with the equation that starts with 243. So that's make sure you're paying attention to that, like those little details on it. And here is just the number A1 is first term, R is the ratio, N is number of terms. So the number of the term that you're trying to solve for or you're trying to figure out. Okay, so let's go to the next slide. Again, first term, common ratio, number of terms. Here is just it broken down pretty simply for you. And then this just shows you how you would solve that. So here's the equation. And then here's how it is solved as you keep going up number of terms. So like second, third, fourth power, it's just showing the different number of terms like that. Oh, real quick, let's backtrack. This little funny looking symbol, zoomed it in for you. Sigma notation. That's what that means. This funny looking E, sigma notation. Okay, again, here's an example of a sequence. Here's how you would place the numbers in the sequence or like in the equation. Here are the number of terms and how it goes up like this. As you can see, again, we have 2, third, fourth, fifth power like this. Sigma notation. All right, here we go with this lovely looking symbol again. Sigma notation can be very efficient way to write a series with many terms. Meaning it's a good way to like condense it down, shorten it. That way you're not writing everything out and like wasting a ton of paper or space. This is a way to like just condense it all together. So far we've looked at the sum of a series with only a few terms, but What if we want to quickly find the sum of a series with 100 or more terms? We wouldn't want to add each term by hand. Of course not, because then that's going to take forever. And that's why you condense it down like this. Okay, I'll skip this and let you do that on your own. So some of a geometric series, here's how you would do it like this. Here's our equation right here. Number of terms again, first term common ratio. So this sequence is 50 terms, and here's how you would solve it if it has 50 terms. See? Okay, so then we'll let you figure that part out. And let's take a look at this one. So school lunch and nesting dolls. Let's read it together. Maggie started and signed a petition to add a new item to the school lunch menu. Okay, on Monday, she asked 3 friends to sign the petition. On Tuesday, those 3 friends ask 3 friends to also sign it. If this continues through Friday, how many people have signed the petition? So like 3 friends, then 3, then 3, then 3, and so on. It keeps going up and up and up. Verify. Okay, so here's how you would set up the equation for that. And by Friday, say 3 friends, they keep asking 3 people and 3 people and so on. You'd have 364 people signing this petition if you did it like that with 3 and 3 and 3 and so on. Pretty interesting when you think about it. Now, it just gives you some examples of geometric sequencing. This talks, Khan Academy is also great for extra resources and extra practice in math. This one, let's read about the nesting dolls. If you've ever seen these, another name like Petrushka would be another name for it. They're pretty cool because inside the doll, there's a smaller one, a smaller one, a smaller one, and so on. It keeps going. Okay, so an artist is making a series of nested dolls. The height of each doll, the largest doll, is 16 centimeters. The other dolls are each 80% of the height of the doll before. What is the total height of all 4 dolls? Let's find out. Okay, so here's our equation, and we want to know the height of all 4 dolls together. Here's how you solve it. So the total height of all 4 dolls, about 47 centimeters. And that's how they all fit inside this one doll. So the little one goes in this one goes in this one, and so on. And then they're all combined together. So basically, like you take a top off, and that's how the dolls fit inside each other. It's pretty cool. I used to have one of these when I was younger. Okay, and again, we have some problems here. Scroll down. I'll let you figure these out on your own. All right, using a geometric series to solve problems. All right. So let's go to the next part. Shows an equation, shows how to solve a problem. It's just giving you basic information going down the series and what to do. Okay. And structured savings plans. Here's what you do in a savings plan. Here's how you figure this out. Okay. 3% interest is just giving some examples of savings plans. Saving money, how does your money multiply over time? If it's got this interest rate and so on. Pretty cool when you open up a savings account. Definitely recommend that. Okay, so this talks about loans, taking out a house loan. Now, like taking out a mortgage, for an example. Now, say there's an interest rate on the mortgage plan, which there are interest rates on loans, and then over time, like you end up paying like a little bit more. So here's the loan amount, and let's go down. Okay, so say the monthly interest rate is 3.6%, okay, or 0.003. Okay, keep multiplying this as time goes on. You end up paying sometimes, let's see, the amount it would have been in the savings account after 30 years is about 608,563. Okay. So it's just showing what happens as time goes on with a loan. Sometimes interest rates can make a loan, like you end up paying a little bit more money as time goes on because the interest rate is really high. So let's say a loan had an interest rate of 10%. you end up paying a little bit more. Okay, so here's just more examples of that and what's going on. Shows you, okay, here's a payment of, we'll go down to the bottom here. The monthly payment for a loan of this 207,000 would be about 941.12 cents per month. Pretty interesting. And here's some more investments information, questions. I'll let you solve that on your own. And we are at the end of this tutorial. Hopefully that gives you a better understanding of geometric sequencing and examples. Hopefully that clears a couple things up for you. And yeah, and as always, review some of the mini lessons I have on this. They should definitely help you as well. Enjoy.